Hello, everyone. Welcome back. Today, I'm going to be talking about normal sampling and modeling. So, just a reminder, if you have not seen the previous lesson about normal distributions, introducing them, do make sure you go watch that first because that is going to make this video make a lot more sense. So, that said, let's get into normal sampling and modeling. Here's an example. It says the Johnson family orders pizza from Pizza Shack every Tuesday night. Including the cost of the pizza, delivery charge, and tip, the last 10 orders have cost $23, $25.50, $27.50, $33, $34.50, $26, $24.50, $32.50, $28, and $36.50, and assume the data is normally distributed. Determine the mean and the standard deviation for this data. Okay, so the mean is relatively simple. The standard deviation is going to take us a while to solve. So remember back in, I think it was unit 2, when we talked about how to find the mean and the standard deviation when we were given you know, various data points. We're going to do the same thing here. This first question, actually, we actually don't need to know that it's a normal distribution in order to do this. This is stuff back from Unit 2. Now, that said, Unit 2 was a while ago, so I do think it's worth going over it again, and so I'm going to do so here. It's really the, question B and question C and question D that we're going to need to use what we learned in the last lesson in order to solve this. So let's figure it out. So first of all, how do we calculate the mean? Let's review. To calculate the mean, we must find the summation, the addition of all the different x values, and we must divide by the number of x values there are. So if we add those things up, if we add 23 plus 25.5 plus 27.50 all the way to the end, we get that in total, all the last 10 orders cost $291, and there were 10 orders. So that means the average order, the mean order, cost $29.10, right? $29.10, which sounds about right because there's quite a few nights that it cost them a little bit less, but there's also quite a few where it cost them a little bit more, but that does sound about right. Now, how about the standard deviation? How do we find the standard deviation? What we must do is we must take the summation, the addition of x minus x bar squared over n minus 1. Now keep in mind it's n minus 1 and not n because this is a sample, right? We're taking a sample of all the orders, right? I'm sure that the Johnson family, if they order from Pizza Shack every Tuesday night, they don't only do that 10 times, then they stop. They're just saying this is just the last 10 orders, but they will continue to do this after these 10 orders. And they also did this before these 10 orders. Tuesday night is just in general, it's pizza night for the Johnson family. So, because this is only a sample of all the times the Johnson family's ordered pizza, that's why we must put n minus 1 in the bottom rather than n. So do make sure to do that, otherwise you won't get the correct answer. Now, how do we find all of those things? Well, let's do that. Let's do that step by step. So let's put in all our x values here in one column. Then we'll do all our x minus the mu videos, which in this answers, which in this case is 29.1. And then let's do all of these values squared. So that way from each column to the next, it won't be so hard on us. All we have to do is one step at a time. Okay, so how much did the orders cost? Let's see again. They cost $23, 25.5, 27.5, 33, 34.5, 26, 24.5, 32.5, 28, and 36.5, right? So those are the answers about how much did it cost, right? Okay, so now we're going to subtract 29.1 from each of these. So 23 minus 29.1 is negative 6.1. 25.5 minus 29.1 would be negative 3.6. 27.5 minus 29.1 is negative 1.6, and so on, right? All we're going to do is continue that pattern and just think about what these would be. You can also use a calculator if you need to, although likely you won't need to for this part, but you can if you'd like, or you can to check your answers as well. You will be able to use a calculator in general for, in general in statistics, regardless of level, it's usually pretty common that you do get a calculator for tests. There we go. And now we're going to take all these values and we're going to square them. So this part you may want a calculator for, because most of these probably you don't know off the top of your head. If you do, fantastic, but that's fine if you don't as well. So let's see. I'm going to grab a calculator here. Negative 6.1 squared is 37.21. Negative 3.6 squared is 12.96. 1.6 squared, that's 2.56, and so on. Let's see, 15.21, 29.16, 9.61, 21.16, 11.56, 1.21, 54.76. There we go. Awesome. So now what we must do is we must take all of these values and add them up. So what do we get if we add all of them up? Let's see, we get 195.4, and then that's divided by 10 minus 1, which is 9. So that's going to be 4.66. So therefore, the sample mean is 29.1, and the standard deviation is 4.66, and that's what the question asked for. So I'm actually going to highlight the answers here. The answer for the first part of the question is that the mean is 29.1, and the answer for the second part of our question is that the sample standard deviation is 4.66. Good. Okay, so next let's move on to part B. Part B asks, what is the probability that the Johnson's pizza order will be less than $25? So keep in mind, the average is 29.1 and the standard deviation is 4.66. So probably not that likely, definitely possible for sure, but probably not that likely. And keep in mind, this is the normal distribution, not the exponential distribution, where we're actually more likely to get things sometimes that are less than the average. In this case, we're not. In this case, because it's less than the average, we know that it's less likely to happen. Good. So what's the probability it will be less than $25? Well, let's see. Let's see about that. Probability of X being less than $25 is associated with what Z-score? Well, the Z-score where X is $25, X bar is $29.1, and sample standard deviation is 4.66. So we actually were using what we learned in the previous part to do this part of the question. So that's going to be, so the Z-score is going to be the X value, 25, minus 29.1 over 4.66, which if we do that, that's going to be 0.19. So that means the probability that, I think I've done that incorrectly. I have done that incorrectly because we should get a negative number if we do that correctly. That'll be negative 0.88. There we go. That's the right answer there. Okay. So now what we need to do is we need to say, well, the probability of the order being less than $25 is the same as the probability that the Z-score is less than negative 0.88. Okay? So what's the probability of that? That's a good question. How do we find that out? Well, we go to the Z-score table. So we were looking for the number negative 0.88. So let's do it. Negative 0.8. Oh, well, that's here. And then 88, that would be out here. So it's that one there, 0.1894. Okay, so let's do that. 0.1894 would be our answer. So about 18.94%. So just shy of 19% there. I have a chance that the pizza order will be less than $25. And you know what? That makes some good sense. That makes some good sense. We were expecting it to be, not a super high probability, given that the median, or sorry, not the median, the mean would be 29.1, which is greater than 25. Good. The next question asks, what is the probability that the Johnson's pizza order will be more than $30? Well, the thing is, $30 is a little bit above that mean, right? That's a little bit above the 29.1, which is our mean. So we're expecting this to be a little bit smaller than 50%, but close to 50%. My guess is this number will be between 40% and 50% approximately, given what the question is asking us. So let's see what it is. So probability that X is greater than 30, that their pizza costs more than $30 today. Well, that means X is 30. X bar, as we know, is 29.1 as always. And S is equal to 4.66. Okay. So then here we have Z is equal to 30 minus 29.1 over 4.66. Let's plug that in. Can be 0.19 once that's plugged in. Awesome. So now we have that the probability of X being greater than 30 is the same as the probability of the Z score being greater than 0.19, which means that that's the same as 1 minus the probability that the Z score is less than 0.19. So what's the probability that the Z score is less than 0.19? Well, let's go find out. I'm not sure. Let's go find out. Actually, I'm going to get rid of all these other numbers from previous times. We want to know about 0.19. So here's 0.1, right? And here's 0.09. So it's going to be, this one right here. That's the right answer right there. 0.5753. So let's write that down. 1 minus 0.5753. Which is equal to 0.4247. And that's the answer. The probability the Johnson's pizza order is more than $30 is 42.47%. And there we have it. There's our answer. Okay. The next question asks, what is the probability the Johnson's pizza order will be between $25 and $30? So this one, actually, I don't think we have to use the Z-score table again. I think we've already done what we need to do. We just need to think about this one and answer it. So the probability that the pizza order is between $25 and $30 is equal to the probability that the Z-score is between 0.88 and 0.19, right? Because we already found those values earlier, which is the same as the probability that the Z-score is less than 0.19 minus the probability that the Z-score is less than negative 0.88. Okay, so what was the probability again that the Z-score was less than 0.19? Well, that is this value right here, right? This value that we found on the table, this 0.5753. Like that. And then the last one is the probability that that the Z-score is less than negative 0.88, which is 0.1894, which is 0.3859. And there we have it. So the probability that the pizza order will be between $25 and $30 is going to be 0.3859. And there we have it. All right, so next time we're going to be talking about the normal approximation to the binomial distribution, which was the one of the distributions we learned about with discrete variables. So we'll talk about that next time. But good work today, everyone, and we'll see you for that next time. Bye, everyone.